optimization and integration of network teaching resources of ideological and political cause based on the big data. Ming-sheng and Li-jun, Baotou Teachers College in Mongolia. Abstract. In the current optimization and integration method of teaching resources, in the design of teaching resources integration method, the compatibility of the method framework is poor. When the conditions are changed, the integration efficiency will be greatly affected. Therefore, this paper proposes the optimization and integration method design of network teaching resources of ideological and political causes based on big data. Firstly, according to the data mode of big data, the resource integration model is established on this basis. CFI generalization framework is used as the resource integration framework, and the calculation method of data classification is added in the framework. Finally, computer technologies such as DOI and cross-ref are added to the framework to realize the integration of network teaching resources. In order to verify the feasibility of the integrated method, taking the network teaching resource data of ideological and political course of a university as a career, experiments are used to verify the data optimization and integration effort of the designed integration method. The experimental results show that the design method is less affected by constraints, and the integration efficiency is high, which meets the design requirements. Keywords: teaching resources, CFI generalization framework, big data, resource integration. Introduction. The traditional information carrier system is dominated by paper-based carrier, and a stable system structure is formed by the mutual compatibility of paper-based carrier with microfilm carrier, magnetic carrier, and laser carrier. With the popularization of network digital technology application, all kinds of information began to transform in digital form, and digital information will continue to grow, and the speed will be accelerated. Digital information has become the mainstream information resources. The Internet has become an important channel for people to obtain information knowledge, and people's behavior of obtaining information has also changed. For colleges and universities, digital resources can be convenient for the allocation of teaching resources. However, the growing number of complex digital resources, such as overlapping content, redundant information, and low knowledge relevance, have formed digital resource islands and digital resource overland. Digital resource island is the diversity and heterogeneity of storage digital resource system, which leads to digital resource. It is an information environment state that is difficult to obtain and share. Digital resource overload is due to the large number of digital resources, which makes it difficult for people to accurately obtain information resource. These two dilemmas have brought a serious burden on people's utilization and access. Researchers at home and abroad have established a variety of resource integration systems, such as Encompass with Link Finder Plus and Millennium Access Plus Map. However, in the actual use of the system, it is found that the system lacks the consideration of different constraints in the application. When different constraints are added to the resource integration, the integration running time will be significantly increased, and one-step optimization is needed in actual use. Framework of teaching resources integration. The paper uses CFI generation framework as the resource integration framework. From CFI generationalization to more extensive scenarios, it can be found that in the context of service ecosystem, the fundamental task of service resource integration is to select paths optimally according to the personalized needs of users or applications and individuals from virtual resources. The framework includes three parts: input, output, and source integration. The input includes service resource pool, application requirement description, and service resource quality. Service resource pool is the collection of service resources. The same large class of resources can be in different subcategories, in different classification standards, and has different evaluation criteria. Application requirements description is to describe and express the personalized needs of users in a standardized form. To be able to describe and understand users' requirements is the premise of personalized service resource integration. The quality of service resources includes the quality attributes of all aspects of each resource, which can be examined from two aspects: the quality records of the historical use of resources and the quality declared by service resource providers. The output is the result of the integration of service resources, that is, a set of resources obtained by matching and selecting resources. At the same time, these resources may be in different positions in the organizational structure of the collection. These common points are and internal relations make these resources together form a resource set which can be better meet the user's personalized application needs. When generating multiply result sets, they can be divided into different priorities according to the different evaluation results. The resource integration engine implements the service resource integration method according to the personalized constraints of user requirements, the category and quality characteristics of resources. A set of resources is selected from the resource pool to form a virtual service resource that can meet the needs of users. The description of resource integration needs to conform to the description of service resources. In reality, the resources in a certain field are often classified according to different standards, which are reflected in the multi-dimensional classification of service resources. In addition, domain resources also have a certain number of general attributes and domain attributes, which are reflected in the multi-attribute of service resources, as shown in Figure 1. Resource matching and integration technology. The integration of digital resources is not only to gather digital resources together, but also to describe, organize, progress, sort, search, service, and other aspects of information which needs to be supported by certain technologies. At present, there are several digital resource integration technologies that attract people's attention. Using DOI technology, the unique identification code is established in the data. Its function is to assign permanent displacement identification code to digital objects. DOI provides users with permanent access to digital resources by passing DOI. When users click DOI to ask for information, their requests are sent to the central server. The server passes DOI into URL and returns it to the end user, which enables users to access the resources. Cross-ref is used to develop the reference link, and through this link, users can retrieve the metadata database and address database of cross-ref in different teaching resources so as to obtain the corresponding DOI, URL, and metadata. At the same time as SFX technology is adopted to it, which is actually a context-sensitive reference link based on the Open Unified Resource Locator standard. This technology is actually a third-party service component between the link service provider and the information resources providing the link source. After receiving an open URL, the component obtains the metadata through parsing and obtains the metadata through the identified file provided by the open URL to the relevant server, and then through the metadata, SFX can transfer the metadata to the relevant server. Thus, this is no barrier between information resources and heterogeneous communication protocols. The overall integration progress is as follows. Experimental methods. 1.2 Experimental results. Throughout the 5 application service instances, the platform will merge them into one secondary server. After the generation merging, each application will add the corresponding load as shown in Figure 4. Figure 4. Load curve of experimental application. With that gradient increase of each application load, the server load increases and the resource usage of each application server instance increase, resulting in the bottleneck state of the only host server at present. At this time, the server splitting operation will be triggered, which will cause the platform to gradually split some cluster nodes into other servers, increasing the number of working servers. In this paper, under the condition of big data, the similar optimization effect is calculated. Four methods are used to integrate the experimental teaching resource data of ideological and political courses in college and universities. The operation efficiency in the integration process is shown in Figure 5. Conclusion. In this paper, the big data model is used to establish the optimization model of teaching resources. At the same time, through the optimization of the framework, the operation efficiency of the integration method is higher. However, in this paper, due to the use of big data model to build the integration model, so the integration needs to be connected to the network and through multiply servers, so there are still limitations.